Electrochemistry. Voltaic or galvanic cells is a device in which the chemical reaction produces an electric potential difference between two electrodes. Here's an example of zinc and copper electrodes are immersed in solution zinc 2+ and copper 2+ ions, which are separated by a porous membrane which prevents bulk mixing. The process at the anode follows that zinc loses 2 electrons and becomes zinc 2+. The process at the cathode follows that copper 2+ gains 2 electrons and becomes copper. Here's an example of the cell diagram notation which you will use on the handout. It is written from anode to cathode, so zinc is first, followed by one line notation which indicates a phase boundary. Next is the solution that it is submerged in. Then the double line notation divides the two half cells and the electrons flow from left electrode to the right electrode. Then it is followed by the solution of the cathode, then another one line notation, and lastly the anode itself. The equation at the bottom you'll need to keep in mind, which is that E cell equals E positive lead, which is the cathode, minus E negative lead, which is the anode. For this experiment, this is the module and the 5 different solutions we will be using. Once again, the negative lead, also seen as the black cord, is the anode, and the positive lead, which is the red cord, is the cathode. You should have gotten your handout from Blackboard. If not, you can go ahead and do that now. For the first column, you're going to write down the voltage. For the next 2 columns, you're going to identify which one's the anode and which one's the cathode. The anode is going to be the black cord and the cathode is going to be the red cord. For the last column, you're going to write the cell diagram notation. If you're having trouble, you can look back on the example I gave in an earlier slide. Now we're going to see the effective concentration on voltage with 2 solutions with the same cathode and anode. The first one we're going to see is 0.01 copper nitrate solution.